afternoon, ladies and gentlemen. The first presentation today will be delivered by Tony Luo from AMI. The topic is Near Field Communication, NFC, and UEFI. Please join me in welcoming Tony.
Thank you, Molly. So, good afternoon. This is Thursday. So, glad to see still so many attendees today. Hopefully your coming is not only for lunch. Okay, so yeah, today I gotta share you some news in UEFI, so NFC, Near Field Communication. So when people ask me what is purpose and what this can do, so from the presentation today, I would like to bring you some NFC knowledge, so you have some basic understanding, and then we will show you the proposed UEFI NFC Stack. Also let you know a simple use case for that, and you can see how to adapt this to your product. So this is the agenda today. I'm gonna let you know the NFC technology, some overview of that, and show you the NFC stack, the block diagram, and give you some explanation and some conclusion for that. Introduction. So everybody knows that NFC is a famous, it's a popular payment interface. So actually NFC is not only for payment. There are so many areas in your daily life you already touch NFC. Such as like NFC you can use as an e-ticket. So it's also popular in transportation system. So also for the toy and the gaming. So at my home I have a toy is called Skylander. It creates a lot of models. So there's NFC Tag embedded in the model. So it's also support a cross-platform. Cross-platform not for PC platforms, for Xbox, PS4, and DS this platform. So in the same model, you can adapt to all the systems. So what it did, so the platform will sense the tag in the toy, and then you can bring the toy to life to your game. You can play with it. So you can store data in the tag. So I'll give you some further information about how the tag works. So NFC can also use this identification. So you can store some user credential in the NFC tag. And for NFC, we also support the peer-to-peer access. So peer-to-peer means you can exchange the data using NFC. Just like a popular function in Android phone, you can exchange the contact information by touch your phone to each other. So that's some important application for that. Another important application is for peripheral. So like right now, so many people like a Wi-Fi access point, also some Bluetooth headphone. They have NFC tag embedded with it. So whenever you want to do the pairing, everybody knows that Bluetooth needs pairing, right? So you can use your phone to touch the phone, and it will pair automatically. You don't need to do any manual process for that. Okay, so here for this session, I'm going to show you some important NFC technology information. The first is some important characteristics of NFC. Everybody knows that it's a short range, it's contactless connectivity interface. So in the spec, even is 10 centimeters, but normally it's around 4 or 5, even less. So it's close, and it operates in the band is ISM band. ISM stands as industry, scientific, and medical band. It's not a reserved band especially for NFC, so many industry standards can use this band. You can allocate your radio frequency for your access, just like Bluetooth, Wi-Fi. Also, some version may consume this band as well. So this band is actually a subset of RFID. So NFC stay with this. So there's no specific reason. And for NFC, the communication speed is slow. It's only 106K to 424. So the speed depends on the NFC reader chip capability or the tag, which tag spec you stay with. Here I would like to let you know for the NFC there are mainly 3 modes. So the first mode is the tag reader and the writer. So what it is, so everybody have a mobile phone. So actually there are NFC reader chip embedded in the phone. So whenever you can use your phone to touch the tag to read, normally the application is read the data. Actually you can write the data as well. You can write some information to a protected graph. But normally the phone will not do that. And another mode is peer-to-peer transfer. As I saying that you can, like right now the practical application, you can exchange the contact information. Actually you can use it to establish the connection also. So what I'm saying is establish connection. You can use the NFC to establish connection, then the bulk data transfer can be used through the Bluetooth or Wi-Fi. Another important application mode is card emulation mode. So what it is, so NFC you can simulate as a smart card. Smart cards, you know that you can run JavaScript, you need a crypto engine. So it's an important mode for the payment. So you can secure the payment. So payment is run through this mode. So it also needs chip capability for that. And for the NFC stack we got proposed today, we address only the tag reader writer mode and the card immersion mode. Here I would like to give you some overview of the NFC technical specs. Yes. Just like the other interesting, there are so many specs. So, but I'm not go through all the detail. Just let you know, actually there are 3 modes and which inductive spec support the modes. So there, if you would like to start it, do some deep dive of NFC, I would suggest to start with the tag type spec, also the NDF. NDF stands for NFC Data Exchange Format. So many NFC tags, so how to communicate with the tag. So NFC format defines some certain format to exchange the data. And here I would like to introduce 5 major NFC tag types. So different tag types represent different storage size. So NFC storage size may be 1K or to 1 meg, depending on the tag type. Also the transfer speed is also varied. Also for some tag type, they also have the security support. You can only access the tag data through the authenticated key. So the tag type 1 is Topaz. So actually it's created by InnoVision. So InnoVision is acquired by Qualcomm. Qualcomm. So Qualcomm owns the technology. But the Topaz is the trademark of that. And the second NFC type is NXP Semiconductor. So it's formerly Philips Semiconductor. So the MyFair is the trademark of NXP. So for the tag type 2, they give you another trademark called Ultralight. And the type 3 is proposed by Sony. It's called Felica. So it's also popular. It's widely adopted in Japan. So when you visit Japan, most of the transfer systems are using the Felica technology. And the type 4 is also still NXP. It's DES5. And the type 5 originally is NXP proprietary spec, but I proposed to NFC Forum and NFC Forum approve it. So the last type is the MyFair Classic. So there are totally 5 NFC tag types available in the world now. Here I give you some example of the NFC tag. So actually there are no big amount of memory block available in NFC. So this picture actually I acquired through the application. So in your Android phone, you can install an application called NFC Tag Info. So whenever you have NFC tag, you can use the tool to sense some information, a lot of information regarding the tag type, tag vendor, and also some information. And actually you can also write the information to the unprotected graph. So there are many applications available on top of it. So for this is just a sample data. So for the NFC tag, like you can log some specific block or unlock it. So, and also some data you can also make it write once. It depends on the tag capability. So here is a simple format picture I captured from the spec. So if you're interested, you can take a look at the spec. Okay, here is all the NFC basic knowledge I bring to you. So far, okay, I think everybody knows NFC has 3 modes: tag rewrite mode, peer-to-peer transfer mode, card emulation mode, and NFC have tag. So the tag spec has many 5 NFC tag types. So once you have this basic knowledge, maybe you can start to think about what kind of application you can add to your product. And from this session, I would like to introduce a proposed NFC stack, which we already implemented. Yeah, here is the block diagram of the stack. I will explain this stack from bottom to up. Okay, first, to support NFC in your system, you will need a reader chip, a reader-writer chip to sense NFC tag. You can read or write the data, and you need antenna embedded in the system as well. So far, normally, mainly mobile system like phone have NFC reader. But if your target platform is a desktop or notebook without NFC, actually you can buy the off-shelf the NFC dongle to have this capability. And for the NFC reader chip, there's a UEFI NFC chip driver need to create for it. So far, the main market chip using the vendor-specific protocol, so we need to create a vendor-specific driver for that. And we create one UEFI NFC host controller protocol to abstract the controller's specific task. I will show you the protocol interface later. And in the higher level, we have the NFC management driver. What it is it will collect the information of NFC controller, also maintain the information of the NFC tag, the sense tag, such as the vendor, also the memory block size, something like that. And then there's the NFC tag blocks to support NFC tag types. The main reason we choose the MyFair Ultralight, the Classic, is the most popular right now in the world. And for this layer, there's one UEFI protocol. UEFI NFC protocol is produced for higher NFC application access. So I will explain some function later. Here's the protocol function provided by UEFI NFC protocol. So the first function is get capability. You can know whether any reader chip available in the system, what kind of capability it provides. And the second function, you can invoke this function to know is there any NFC tag is sensed. So in the future function, read and write, once the tag is sensed in your UEFI driver, you can invoke this function to read or write the data in the NFC tag. And the last function is card emulation. So you can use this function to emulate NFC tag in your host system. So what's the purpose? So once you emulate the tag, you can use the phone to touch your system to get information, to exchange the information. And this is a UEFI NFC host control protocol. It sticks with the UEFI NFC protocol. It abstracts the read and the write function. And for the tag sense command, we need to send a chip. So all these functions create for chip specific. Okay. Some people ask me what the NFC stack can be used. So here I just give you a sample use case for that. Such as like we don't always have the password, right? So you can store the password credential in the NFC tag. The NFC have some memory, some even the size is small, you can still store the password in it. So when you system problem, originally you need the user to manually type a password. But once you consume this stack and the support NFC tag, so you can read the password from a tag. Just kind of automation. Something like that. Actually, there are some more use case available. For the UEFI request me to cut off the slides. But anyway, right now you have the best knowledge of NFC and with the NFC stack. So actually there are some more applications can be added on top of it. So password check is one of it. So NFC tag have some storage. So if you have some UEFI progress, you need storage, you can use this as well. And they can actually, there are another application I said right now in the end user world is there are many tags available in the world, so you can program a tag for specific action. Just like you can have a tag at your office, you can have a tag in your home. So whenever you arrive office home, you can use your cell phone to sense it. So some application or some more, maybe automatic alarm, something like that. So your UEFI, you can account the same thing. Maybe you can say, you can sense a tag to maybe go to setup or something, or involve the bus recovery process. Yeah. Right now, another popular application in NFC is some car that using the NFC as a key to start it. Just to give you some idea, so maybe you can think about it. Okay. So here comes the conclusion. It's fast. So for who interested in the NFC stack or technology, so see if you can find a chance to review the proposed NFC stack. And then we also will initiate a discussion in the UEFI work group. So feel free to join it. And to support NFC, we may also need to invite the NFC chip vendor, also the tech vendor, join the discussion, come out with a robust stack to support the feature we'd like to have. And here is some reference website for you if you want to pick up some NFC technology for your reference. Okay, that's all my presentation today. So, any question? Brian?
So, are you? So, is this proposal, has this been made to any of the USWG working groups yet, or is this still something that AMI is working on privately?
We are consolidating the proposal.
Okay.
So we will propose to USWG.
Okay.
Yeah.
And do you have any sample code for, like maybe a EDK2 staging or some kind of trial, or are you waiting on the proposal to be reviewed before you release any sample?
Yeah, it's a good question. We do have the source code. Yeah, we will do the internal discussion.
Okay.
What kind of we will propose to UEFI work group.
Okay.
Any more questions? Since no, okay. So thank you. Thank you very much.
Thank you, Tony. Now please allow me to introduce Liz Lindholm from Lenaro to give our next presentation. The topic is EDK2 Platforms Overview. Let's welcome Lindholm.
Hello. Better. Hi. As those of you who have been coming to FlightFest for a while, this is my first one in Asia, but I've come to the US once for a few years now. I've been kind of driving this thread for a few years and trying to get more actual platform implementation code into UEFI land, as we put it. As part of that, and I've presented that before, we initially kind of bootstrapped this inside Linaro and something I called Open Platform Package, basically as a challenge for someone to come up with a better name, and no one did, so it stuck. And this is my talk about how Open Platform Package is now dead, because Open Platform Package was always a workaround to the fact that there was no proper process for bringing platform code into EDK2. And as of a few months ago, we now have this process in place, and everything that was an Open Platform Package has now been migrated into a new repository called EDK2 Platforms under the public Tiana Core GitHub area. So, because of the way Tiana Core works, we've split up the functionality that was an Open Platform Package into two repositories. First is the EDK2 Platforms, which is the open source bit, and then we also have EDK2 non-OSI, which is for bits that are not open source in otherwise open source platforms. So we have some partners working around UEFI where their companies do not let them work on repositories that contain binary images, and that's basically the reason why we need to have two separate repositories for that. There are still some platform bits left in EDK2. There's like Core Package, there's the value stuff, there's Beagleboard, and all of that is meant to be migrated across into EDK2 platforms. And EDK2 itself, we retain sort of the virtual platforms and the industry standard code, but new platform code or new open source device drivers would all be going into EDK2 platforms in the future. So the overview of how this has worked in the past, as my experience when I got into the UEFI world anyway, was that whenever you started working on a new platform, you had to sort of go around the entire town and then grab one piece over here from the CPU vendor, and then you had some device driver stuff from there and some other stuff from there. And if you're working with one of the BIOS vendors, then clearly they had some additional packages and so on. So when we moved to the sort of pure open platform package situation, then hopefully we could just keep for the fully open source platforms. We could just work with open platform package, and maybe if we had some own additions we wanted to add on top, we could do that as well. But the problem, of course, was that this was maintained in a completely different organization. It wasn't part of the official Tiana Core project. But these days, we can now have all of this stuff in Tiana Core. But of course, if you want to work on some of the stuff that's upstream in Tiana Core and then still add your own stuff, that still works fine. That's not a problem. So, EDK2 platforms. It's an official Tiana Core repository that holds only open source components. That's the link to it. The master branch is the bit that I'm really interested in, because for me this is a very useful vehicle to really test the generic EDK2 code base. Because if you're always only building on one branch for one platform, then you don't spot the bits where, okay, I need to change this thing a bit here, and we're changing something in this core protocol, and then maybe that breaks a platform, but you don't find that until 2 years later when you come back to rebase that onto a more recent EDK2. So that's where I'm spending all of my time. But we also have the ability to add development branches. So if something is not ready to go into master yet, but we want to share the code so people can have access to it, if we think there's going to be a longer upstreaming process, then people can have a development branch. And also, some partners expressed an interest of having what they call stable branches, which is things that if they have a platform which they want to have open source and give people access to, but they don't want to spend the effort of tracking developments in core EDK2, then they can have what's called a stable branch that's tagged against a specific UDK release. As I mentioned, any sort of new open source device drivers are being added into EDK2 platforms. EDK2 non-OSI, as I mentioned, it's the bit where in open platform package we permitted inclusion of binary-only components in order to get code that you could rebuild against later EDK2 for certain platforms that still needed binary modules. EDK2 platforms does not permit any binary modules, so they go into a separate repository called EDK2 non-OSI. And as I'm pointing out, there's also, if you were to have something that had, should we call it a questionable source license, and actually have the source, something that, for example, does not permit redistribution, then that would be something that could also go in here. The important thing to realize about EDK2 non-OSI is obviously because it exists for the very purpose of being not a fully open source EDK2 Tiana core compatible thing. There is no default license for this tree, so any component that's being added or any subtree that's being added needs to explicitly specify its own license for the contents contained under there. Sorry, I might have gone slightly overboard with squeezing information in on this slide. Hopefully you can see a bit. So the practical changes of this. We open platform package, I sort of just basically treat it as if it was a package in EDK2 top level. So I would either use a Git submodule to import it, or just put a symlink to the repository to build it. When we move into EDK2 platforms, then instead we make use of the EDK2 packages path feature to add that to its. We no longer have a special prefix in the platform description files to locate the different packages. When I made releases based on open platform package, as I mentioned, I used Git submodules. We're not doing that anymore, so if anyone was working with that, you're going to have to find a new way of dealing with the fact that you're making a release based on multiple repositories. There are various ways of doing that. You can use like the Android repo tool to manage that. There's another tool called Many Repos. For now, I've done a silly thing and just put up my own Git repository that holds a configuration file with a few Git hashes of which ones I care about for each repository, and I run with that. For people who want to contribute to development of EDK2 platforms, want to submit drivers or patches, this now happens on the main EDK2 development mailing list. In the past, I had this Linara mailing list, Linara-UEFI. It still exists, but if you want to get code into EDK2 platforms, it needs to go onto the EDK2 development mailing list. In order to help people who don't care about the platform's code, any patches sent should be sent with a subject prefix which people can filter on and maybe throw into a subfolder. And similarly for non-OSI, so you can filter that out and just keep the main things if you care about it. So yeah, the actual images you build will be built across a series of multiple repositories. Platforms already included. We have some of the AMD ARM Seattle platforms, the Soft Iron Overdrive 1000, the Soft Iron Overdrive 3000, I think they call it formally. So that was also the AMD platform in the first place. And we had a not very successful development board that came from Linara/96 boards called Jello. So those are all supported. The ARM development platforms, obviously, so the Juno platform, the Versatile Express platforms, including the fast models versions. HiSilicon, D02, D03, D05. Partial support for the iKey development board, but not complete. We're still working with those guys to try to get all of the bits repository. They kind of keep their own fork on their own GitHub for now, which is full support. We have the Marvell Armada 7000 evaluation board support. We are working on getting the Armada 8000 support. The Armada 8000 is basically a superset of the Armada 7000, and the Armada 8000 was used in the Marvell / Solid Run Macchiato bin development board, which is what I brought with me to the PlugFest for integration testing this time. So that should all be upstream within EDK2 platforms within the next few weeks. And we've also started adding device drivers. So one thing we have is for platforms that don't have their own hardware random number generation, there's a cute little device called Chaos Key, which is just a USB device you plug in, and that then ends up exposing the UEFI NFC Protocol. Future platforms, as I said, going to move the mass bits across from EDK2. I mentioned the Armada 8000. There is a SocialNext ARM-based platform that's currently going through review on the list, and I'm hoping we're going to see them in Abort 3 as well. Brian?
So there's already 3 Intel platforms in the branch of indicator.
Yeah, sorry. So Intel already have platforms in the, as I mentioned, the stable releases on which are tagged against UDK releases, and I'm trying to keep nudging them to bring some stuff into the master branch so we can keep rebuilding and testing that against EDK2 master. Because I'm lazy, I created something. Are you done? Yes. I created something called UEFI tools, so I didn't have to keep remembering how to give all the different command line options to the EDK2 build system every time. And I used to have, as part of that, a script called UEFI build.sh. I have created for this new version for building with EDK2 platforms, because the workflow changes a bit, this new one called EDK2 build.sh. And then I have a platforms configuration file that keeps track of where all the DSCs are, which architecture I'm building for by default, if there are any sort of build time options I want to specify in the command line, and so on. And it also keeps track of figuring out how many CPUs or threads you have on your build machine, and to be able to make the build parallel. An example command line looks like that. If you're actually building in the directory where these repositories have been checked out, then it will also detect them. But unlike the old script, you can also point them somewhere else if you have, say, a shared repository on a file server and you're building a local disk, then that's easier to do now with the old system. And I've also added a new feature here, so you can have, for things like generic device drivers, which can be built in multiple architectures, you can now specify in the command line that you want to build it for multiple architectures in one go. So if you want to give this a test, then the short version of how to test to check out everything and build it is to just follow the steps on this slide. And hopefully that should all work, and the platforms should all build. But I happen to know for a fact that at least one of them is going to break production. This is slightly going off topic, but it felt useful to mention. The Tiana Core Contribution Agreement has been updated from version 1.0 to version 1.1, and that's mainly to explicitly mention documentation contributions as well as code contributions. So documentation contributions to EDK2 or Tiana Pro projects in general now is now supposed to be explicitly under the FreeBSD documentation license. Even ARM's legal department didn't see an issue with this, but if you have some kind of formal agreement about which things you can contribute under and so on, you may want to talk to your lawyers. And since Dong asked me to fill in a little bit on the other crazy stuff that's going on, it's completely unrelated to the rest of the presentation. We had a while back this crazy guy in Suisse called Alex Graff, who I think he took, I don't know if he was on paternity leave or if he was on holiday, and started hacking and actually implementing a rudimentary UEFI interface on top of the U-boot code base. And together with Rob Clark, they've been working now on adding, I would emphasize that it's still very much not a complete UEFI implementation. Alex's goal was to be able to run the UEFI flavor of Grub on top of U-boot. So that they could, which simplifies SUSE's release management, obviously, if they only have one firmware to worry about across all architectures and all platforms. So that used to be quite rudimentary. As of now, we can actually run the UEFI shell under U-boot, which required a lot more implementation than just running Grub. And they now nearly have enough support to run the UEFI SET on top of U-boot, which is something that I personally think is a really good thing, because it gives us a completely unrelated implementation, which from my point of view is probably going to be useful for also flushing out issues in SET, potentially. So even though I work completely on EDK and not on U-boot, I'm quite pleased that we have this additional thing coming as well. Plus, it will make it a lot easier to try to bring some more UEFI-centric standardization into the embedded world, and that's something that will benefit everyone. And I'm here to rush through this as usual, so we have 24 minutes for questions.
Sorry, I probably missed that part. So if we are going to introduce a new platform, we have to work on EDK to branch first, right?
Yeah, any new platforms going in, they will go into EDK2 platforms. But as I said, EDK2 platforms is not a fork of EDK2. It's just a complete repository that holds only the platform code. And then you use the packages path functionality of the EDK2 build system to point it to go, for the build command to go and search in multiple repositories.
Thanks.
Well, if there's anything else, you will find me in the armor room for most of us resting in this presentation.
We brought stickers.
Ooh, Brian brought stickers.
You want a Tiana Pro sticker? Yeah. It's not an open source project, but like stickers.
Okay, thank you very much.
Thank you, Lim-Hong. Please be reminded that we'll be serving complimentary refreshment at 3 p.m. today at the ballroom. The next presentation will begin at 3:30. Please feel free to join us. Thank you.